Okay, so we are back today, Tuesday, March 24th. We're going to continue. We're going to just start today, Unit 8 review. We're going to start with terminology and then a bit of practice with that term, those terms. And then tomorrow, Wednesday, we'll look at naming compounds. And I was able to get a document camera, so we're going to begin looking at Lewis dot structures later this week as well. So let's go ahead and get started. So again, we're going to start with compound terminology. I do want to make a quick note here. I've had several students ask, you guys can take the Google Forms assignments multiple times, and I'll just give you the higher grade of whichever ones you submit multiple times. And as long as you just put your name in the name question, I'll be able to give you your points. So our first term we're going to look at is electron dot configuration. And this chart right here are the different electron dot configurations for our elements, or some of the elements. Now, keep in mind for transition metals, these are not included because they change how many electrons they lend. So electron dot configuration is a model of an atom in which each dot represents a valence electron. So remember, hydrogen is in group 1A, so it has one electron, so it has one little dot. And then everybody in group 8A, except for helium, has 8 dots, and then helium just has 2. Now, there is a specific reason as to why, like, for example, beryllium's 2 dots aren't next to each other on the same side, or carbons aren't paired up or anything like that. And we'll get to that more when we look at Lewis dot structures. Next term is ion. It's an atom that has a net positive or negative charge. This is from either a gain or loss of electrons. So let's look at the specific ions. So from a neutral atom, you can have an anion, which is an ion with a negative charge because it gains electrons, or a cation, which is an anion with an ion with a positive charge, and that's because the ion loses electrons. Okay, so this makes sense because electrons are negatively charged. You gain an electron, you gain a negative charge. You lose an electron means you're losing negative charge, so you'll have more positive than negative charges, so you're positively charged. Next, chemical bond. So it's the force that holds atoms or ions together as a unit. So here we have 2 hydrogen atoms and an oxygen atom being held together by a chemical bond, forming a water molecule. And then the chemical formula is a notation that shows what elements a compound contains and the ratio of the atoms or ions of these elements in the compound. So this is our chemical formula here. H2O says 2 hydrogen, and then there's not a number after oxygen, but it's understood to be 1, so it's 1 oxygen. Next, ionic bond. So ionic bond is the force that holds anions and cations together. This bond forms between metals and nonmetals. So, for example, we have here sodium chloride. And this forms a crystal, and these are solids whose particles are arranged in a lattice structure. Now, I know when we went through this unit, we had a bunch of different crystals and solids that we looked at. We're just going to keep it real basic and just look at the term crystals, that those are the ones with lattice structures. They have specific arrangement of their bonds, and when they grow, they form larger versions of the basic structure. And I found this while trying to find images for the PowerPoint. So here we have sodium and chlorine. So sodium, he wants to get rid of his one little electron, so he just says to the chlorine, just take him, please. And the chlorine's like, don't mind if I do, because chlorine, as the nonmetal, it wants another electron, and sodium wants to get rid of that electron. So next we have covalent bond. And a covalent bond is a chemical bond in which 2 atoms share a pair of valence electrons. Non-metal atoms create this bond. And then polar covalent bond is a covalent bond in which electrons are not shared equally. So a polar covalent bond is just a special type of covalent bond. So for example, here we have water, and oxygen is actually pulling on the electrons more than the hydrogens, so that ends up with being a negative charge more towards the oxygen and positive on the hydrogens. And we'll look at, when we start studying Lewis dot structures, how you can tell if something is going to be polar covalent bonded or just regularly covalently bonded. Now we have molecule, and this is a neutral group of atoms that are joined together by one or more covalent bonds. And then we have polyatomic ion, which is a covalently bond group of atoms that has a positive or negative charge and acts as a unit. So here is a very large table of several polyatomic ions. And some of these we've already looked at: carbonate, ammonium, hydroxide, peroxide, sulfate, all of those. So the difference between a molecule and a polyatomic ion is that molecule has no charge, polyatomic ion has a charge. Both are covalently bonded, so that means that none of them include metals. They're all nonmetals. Okay? So, metallic bond. It's the attraction between a metal cation and the shared electrons that surround it. So these metal cations, they like their electrons. They want to be near them. Alloy, is a mixture of two or more elements, at least one of which is a metal. So these are two alloys right here. So this is brass. We have copper and zinc. And then carbon steel is iron and carbon. So an alloy needs at least just one metal. So it can have nonmetals as well, or it can have extra metals, but it needs at least one metal. Okay, so that is that for the terminology. I'll have a Quizlet on the class website for you guys to study, and then a Google form for you guys to go through as well. Let me know if you have any questions.